Section 8.1 Solving systems by substitution and elimination. But most of the time I will really use the method of elimination. Let's begin by definition. Okay, here are some definitions. A system of equations is two or more equations that are considered simultaneously. And when you have a solution set, it'll be a set of ordered pairs that make all the equations true. So that means if you have an ordered pair xy, you plug in both of those and it should satisfy all the equations. Now a system is consistent if it has at least one solution, otherwise it is inconsistent. A system is dependent if the equations are one and the same line. Types of systems of equations. Here, when you have two lines that intersect at one point, then you have one solution. In this case, x is 0, y is equal to -2. And you have a consistent system of equations where 2x minus y equal to 2 is the blue line and x plus y equal to -2 is the red line, and they intersect at the point 0, -2. Now here you've got an inconsistent system. What happens here? Look at all these two equations. They both have the same coefficients, but the right hand side are different because these are two parallel lines. That means if I solve for y here and solve for y here, you would have the same slopes, but you won't have the same y-intercept. And if this is the case, then will they ever intersect? No. That's why you have no solution. And you have an inconsistent system. Now what's the third case? The third case is when you have infinitely many solutions. That means one equation is just a multiple of the other, which just means that it's one and the same equation. So think about it. One is dependent on the other. That's why it's called a dependent system, because if you multiply this first equation by 2, you get the second one. So it's really one and the same equation. If this is the case, what you're going to have is infinitely many solutions, because every ordered pair that's on the line satisfies these two equations. So you're going to have infinitely many ordered pairs that will satisfy this system. So let's begin with a problem. Okay, but before we do that, let's talk about the methods of solving systems. First is by substitution. The second is by the method of elimination. With a substitution, it says here it works best if one variable has a coefficient of 1. So what you do, you solve one equation for one variable, substitute that equation into the other equation and solve, and then solve for the other variables. And it's easier to understand this method once we get into a problem. So solve the following by substitution. So let's do that. See, either way, if you want to solve for x in terms of y, then you plug in the x in here, you'll get y. Or if we solve for y in terms of the x, then you'll get and plug it into the next equation, then you'll be able to solve for the x. So how about if we solve for y in terms of x first? So let's solve for y here. So when you do that, that means you subtract minus x from both sides. So that means you're going to have y, because that cancels out, is equal to 9 minus x. Now what do you do with this part right side of y? Then you substitute that here so that you'll have 3x plus 4. So instead of y, we write 9 minus x. 9 minus x equal to 30. And the rest, now what happens is when you do that, you just have an equation in one variable, and that's just a simple linear equation. So let's just go ahead and combine terms. 3x plus 36 minus 4x equals 30. And we see that if we combine these two, we get a negative x, and then take off 36 from both sides, Okay, therefore we have that minus x is equal to, that cancels out. Okay, minus x is equal to what happens on the right hand side? Minus x is equal to -6. So what does that tell us? That x is equal to 6. What happens next? Well, then we substitute this back in here. So substitute in y equal to 9 minus x to get y. And that means y is equal to 9 minus 6. We get y is equal to 3. So what is our solution? The solution set would be x is equal to 6 and y is equal to 3. Now does that satisfy our equation? It's easy to check. Let's do that. Is 6 plus 3 equal to 9? That's quite obvious. Now the next one, 3 times 6 plus 4 times y, which is 3. What do we get? Does that add up to 30? We have 18 plus 12. Indeed, they add up to 30, so it checks. So this is our unique solution. You have a consistent system and you have a unique solution, or a unique solution set. Okay, that was the method of substitution. Now what about elimination method? In elimination method, what you do is you want to eliminate basically one variable, and in order to do that, okay, by the word eliminate. So you want to eliminate one variable. So what the first thing you do is you multiply either or both equations by any number necessary so that one of the variables will cancel when the two equations are added together. Okay, so what would be that magic number that we multiply either of the equations? It depends. We'll see. I'll tell you what happens. Okay, so solve by elimination. Now here, suppose we want to get rid of the variable y. So the goal, therefore, in order for the variable y to be eliminated, that means this should have been an 8. If this should have been an 8, if we add these two together, that will cancel out the y variable. So let's do that. So let's multiply this by what will make them equal to 8. If we multiply both sides of equation 2 by 4, so far what you're going to get is, let's go ahead and put everything here. You're going to have 5x minus 8y is equal to 47. So that's still your equation 1 right there. And then now this is multiplied by 4, so everything has to be multiplied by 4. So you're going to have 24, negative 24x, right? And then plus 8y is equal to, now you multiply 26 by 4, what do you get? 104. Alright, now what happens next? Okay, well, we add these two together. When we add, what happens? Well, you're going to get 5 minus 24, that's negative 19x. And see how this cancels out. So that's the idea. We were able to eliminate the variable y. And it's equal to, alright, what is 47? So when we add these together, what is 47? Oh, you have a minus right there. We forgot that. Okay, so what is negative 47 plus 104? That's equal to 57. And divide both sides by negative 19. And what's the result? So therefore that cancels out. X is equal to negative 3. And there, the next thing you could do is just combine substitution. Just plug in x equal to any of these two equations, then you can solve for y. Or another way is we eliminate x, will get y. So I would suggest that we just substitute x into, okay, if this is the second equation, let's try that. So you're going to have negative 6 times negative 3 plus 2y is equal to 26. So what does that give us? That gives us 18 plus 2y is equal to 26. And then of course subtract, and once we subtract 18 from both sides, then we get 2y is equal to 8, which means that y is equal to 4. So the next thing we do is to check, and if we plug it x equal to -3 and y equal to 4 into these two equations, it should satisfy these two equations. The left side should equal to the right side. So basically what we did, we just used elimination to eliminate the variable y, and then we substituted in one of the equations to solve for y. Now if you really want to do substitution all the way, then you're going to have to multiply this by 6 and this by 5 and then add, and you're going to be able to solve for y once the x is eliminated or is cancelled, I guess. Okay, so your solution, you have a consistent system. Solution is x is equal to -3 and y is equal to +4. Now let's look at this exercise 3. It says solve by elimination. So suppose we want to get rid of x, which means we need to multiply the first equation by what? By 3. And what does that give us? It'll give us 6x minus 12y is equal to negative what? What is 14 times 3? That will be -42. And then you have negative 6x. I'm just copying the second equation. Okay, so plus 12y, and notice what's going to happen right here. When we add, okay, let's go, we're going to add. This cancels out. This is going to be 0 plus, again, 0 is equal to 2, which is impossible. What does that mean? That means you have an inconsistent system, okay, because what you've got is that this system of equations are two parallel lines, so you have no solution. Because they are parallel, they will never intersect each other. Okay, now I have added with exactly just about the same problem, except the right hand side is different. So let's see, I've added this, and this is not in your handout, but go ahead and look at the next exercise. Okay, so let's do exercise. I've called it exercise 3A, and again, what's the goal? Make sure that they have the same coefficient to get rid of one of the variables. Let's go ahead and multiply. Suppose we want to get rid of the x, so we need to multiply the first equation by what? -2. That way they will have opposite signs. So I'm going to put the what we did here in this side of the the paper or the slide. You're going to have a 4x, because -2 times -2x will be +4x, minus -2 times 6 is -12y, and that's equal to -72. And then just copy the second equation, so 4x negative plus 12y is equal to 72, and then when you add everything, what are we going to get? We'll get 0 plus 0 equals 0. So when this happens, when you have 0 in everything, that means one is just a multiple of the other, so you're going to have a dependent system, okay, and you will have infinitely many solutions, right? So I just showed you a situation where in the previous slide you have an inconsistent system because those two lines are parallel. Here you have one in the same line. One is just a multiple of the other, so it's one in the same line. That's why you're going to have infinitely many solutions. Okay, now we are looking at solving systems with 3 variables. So how do we do that? Okay, here are just different situations where a solution would occur, or whether or not you're going to have the same solution, a solution exists or not. The graph of a linear equation in 3 unknowns requires a 3-dimensional coordinate system. Okay, some of the possible intersections of planes representing three equations are shown below. So when you have a unique solution, a single solution, it is that when you have three planes, okay, that are intersecting at a common one point. Okay, it has to be 3D because you have three variables, x, y, z. Here you have three planes are intersecting, but they have what they have is a line is what they have in common. Okay, here this is what we have, kind of like a dependent system, because all points are all the planes. It's no longer a line. All the planes are one and the same. They're just multiples of each other. So that means you have an infinitely many solution. Here you've got parallel planes, just like parallel lines, so no solution. Here you have two lines are parallel, and then two planes are parallel, and one plane would cross each other. So there's no solution again because no points in common. Same thing here. Two planes intersect, but not all at the same time. So that means no point in common. Solve the following system using elimination method. Okay, now the best thing if you look at this, these equations, all right, there's x, y, and z, and then the right hand side, x, y, z, the right hand side, and so on. Now it's obvious here that the best variable to eliminate would be z. So what do? You take two equations at a time. Okay, two equations at a time, and then when we do that, we eliminate same variable. So in this particular case, what we're going to do is eliminate the variable z. Okay, so I'm going to have to name this 1, 2, and 3. All right, so let's say, suppose we take, let's take equations 1 and 2. And then, if you notice, we need to multiply equation 1 by what? By -1, so that they will have opposite signs. So let's do that. So I'm going to multiply first equation by -1, which means all of these would just have opposite signs. So we're going to have positive x minus 2y plus z is equal to -5. Okay, now you add that to equation 2, so you have minus 6x minus 4y minus z equals 1. And then what's the next thing? After we've done that, we add. And when we add, look what happens. This cancels out the z. So you're going to get -5x add minus 6y is equal to what? -4. So let's call this equation 4. Alright? Now next, what's the next thing we need to do? So far this is what we've done. Okay, step B. Now we take which equations? Now we take, how about equations 2 and 3? And you do the same thing. But in equations 2 and 3, all we have to do, since they already have opposite signs, all we have to do is just add together. So let's add them. Okay, so let's do that. And what do we get? We're going to get minus 6x minus 4y minus z equals 1. Okay, and then we're going to get, for equation 3, you get 2x minus y plus z equals 2. And then what happens next? Well, just add what we have. This is going to be minus 4x, right? And then this is going to be negative 5y is equal to 3. Now we call this equation 5. So far we have created now two equations out of what we did in steps A and B to create a new system of just two variables. So that's the next thing we need to solve. So the next thing we do is solve now the following. You have negative 5x minus 6y is equal to negative 4. Okay, and then you have negative 4x minus 5y equal to 3. Okay, we're going to solve. Negative 5x minus 6y is equal to negative 4, and then you have negative 4x plus or minus 5y is equal to 3. And we've called this equation 4 and 5. So in order for, let's say we want to eliminate, okay, so we want to eliminate, say, the variable x. So in order to do that, we multiply. So we multiply equation 4 by what? Okay, we multiply equation 4 by negative 4. And then equation 5 by what? By 5. So that becomes, when we multiply through by negative 4, what do we get? We're going to get 20x plus 24y, right? Because, you know, multiply everything by negative, that becomes, by negative 4, that becomes positive, and then equal to positive 16. Next is, okay, equation 5 will be multiplied by 5. So this becomes negative 20x minus 25, right? Is that correct? Okay. Is equal to, then what is this? This becomes 15. Now let's add and see how the variable x is cancelled, and we have negative y is equal to, so once we add these two equations now, we're gonna get 31, right? Is that correct? I believe so. Okay, so now we have y is therefore equal to negative 31. So what do we do with this number? Then we plug it back into one of these equations, then we solve for the x. So let's see, suppose we want to plug it into equation. So substitute to equation 5. Okay, so this becomes negative 4, okay, x minus 5 times negative 31 is equal to 3, and that'll give us negative 4x plus 155 is equal to 3. Now what's next? Well, we put 155 on the other side, so we take off 155 from both sides. What do we have? Well, that'll give us negative 4x is equal to negative 152, because, you know, when you add these two together, you have negative 152. Divide both sides by negative 4, and what is that? Well, this is 4 goes into here 3 times, and then, you know, that becomes 38 when you simplify it. Alright, so now we found that x is equal to 38. What do we do? Well, we go back and substitute these two. Substitute y equal to negative 31 and x equal to 38 into one of the equations. The easiest would be to substitute in the, so x equal to 38 and y equal to negative 31 to equation 3 to get z. So let's go ahead and do that. Okay, so far, what will we get? If we substitute it to equation 3, let's see what is equation 3. Times, plug in 38, right? And then what's next? Minus y, so minus a negative 31 plus z equals 2. And what does that give us? Well, this whole thing, this is going to give us 2 times 38 is 76, then plus 31 plus z equal to 2. And what does this add up to? That adds up to positive 107, right? Plus z is equal to 2. Therefore, z is equal to negative 105, because if we add 107, negative 107 to both sides, you're going to get z equal to negative 105. Now, how do we know whether these these solutions that we got are the solutions to your system of equation? Then check. So the next step is to check, and I want you to do that by plugging into all the equations. Check and substitute x equal to 38, y equal to negative 31, and z equal to negative 105, and find out whether when you plug all of these values into the 3 equations, make sure they all satisfy the 3 equations. And I guess again, it's time to do your homework. This concludes the whole of college algebra.